you recall when you were taught the basic integral, do you remember what the integral was, right? First of all, you started calculus, you learned slope, you learned tangent line stuff, and then you were almost done with that. You're like, thank goodness I don't do the limits anymore. And then, boom, right at the end of calculus, they hit you and they said, oh, well, what happens if we build these rectangles? Remember these rectangles and the Riemann sums? They chopped them up and said, what if those rectangles are smaller and smaller and smaller? Well, today we're just going to take that a step further. What if instead of doing little rectangles over and over and over and over and over, you did like a three-dimensional cube or rectangle, right? So instead of saying this is the area, and I'm going to make the area slices smaller and smaller and smaller, we're going to break this up into a little, you know, whenever you're first born, you get those blockish things to build your little, you know, you give the little kid, the blocks are huge. They're building their things, and they get to Lego, and they got the 4-piece Lego, and then they go down to the 1-piece Lego. That's going to be us, right? We're going to chop the volume up into smaller and smaller pieces. And so to do that, we're going to get to skip through most. We're going to go over the limit definition, right? But you guys are all shaking your head. You already understand. I'm going to take these cubes and make them smaller and smaller and smaller. That means that the integral is going to follow the same notation, but we're going to skip over that limit stuff. We're going to go straight to saying, well, you already know that the limit of these integrals chops up into smaller and smaller pieces. So we can jump straight to, well then, let's just put all of our new tools, our new fancy tools, our integrations, our derivatives into work immediately. So, I'm going to go ahead and point you out to figure 5, right? So, the idea here, calculator? Yep. Yeah. So the idea here is if you want the volume of something, markers aren't as good as the focal work. You can take the area gotten by this complicated beast. Now don't let this confuse you too much. If you're looking at that nice little figure 5, that 3D photo, you remember when you were doing your Riemann sums and you said, oh look, you can do it from the left endpoint, or you can do it from the right endpoint, or you can do it from the midpoint. You guys remember all that stuff? That's what this xij, yij stands for, right? You go to the 1-1 cube or the 2-1 cube in your little grid, and you say, okay, this is how I'm going to determine the height. Do I look in the left corner? Do I look in the upper corner? Do I look in the very middle of the cube I'm getting ready to make? The other thing I'm going to point you out whenever I always think about this, I always think of, I have no idea what these things are called. They're like 2 pieces of glass. You have like metal rods, and you get to put your hand in it, and then you move your hand, it has your handprint. Then you get to put your face in it, it has your face print in it. You guys know what I'm talking about? That's what we're doing here, right? Only you could do it with the small screws or the larger rods. What we're doing is we're putting our handprint in this device, and we're saying that's roughly the area of my hand. Here we're choosing the point 1 to take. The delta A stands for the width of those Lego blocks. Yes?
I'm kind of confused with the notation there.
Sure.
So what are those asterisks?
That's what I'm saying is, so that is, so say we're looking at this thing top down. All right, so we have a cube here. Sorry, this is going to take me forever if I keep drawing it, so I'm just going to make this quick. All right, my really crappy cube. This is why we have 3D images and get ready to pull some up on the board, right? But the idea is, okay, I've got to fill this block in, right? How tall will this one go up? Well, if you're looking at it from above, right, if I'm putting my hand down on it, I can find the pressure point here to see how tall it is, or here to see how tall it is, or here to see how tall it is, or here, or here, or here. This is the, say, 2, 3 cube in my nice little block. Where am I going to find the height of it? Do I look at the left? Do I look at the right? Do I look at the top? Do I look at the bottom? So if I have, say I'm trying to, I'm going to lose my plot in the book right here, right off the bat. Say I'm trying to figure out how much volume this desk is, right? So I'm going to build this desk out of these books. So the question is, as I'm going up, so each block I build has area of one of these books. where do I decide to cut it off? If I'm approaching this thing, do I cut it off when I hit here? Or do I cut it off on the left or the right or the top? Right? If I'm pushing down, what determines on that surface, on that uneven surface, where I'm going to call the height? We don't need to worry too much about this notation because you know from previous classes, sorry, my inability to draw 3D pictures is really hampering my ability to explain what's happening here. You know that you did this using left endpoints, and you did it using right endpoints, you did it using middle points. But then in the end, do you remember what the big revelation was? When you started chopping this up into infinitely many pieces, what was the big hurrah that kind of happened?
It didn't matter.
It didn't matter. So, in the end, to answer your question, this is any point we want inside the xij slice. I'll be able to give you a better answer in just a minute when we look at example 2 in the packet. But in the end, this xij, not going to matter because we're going to slice it up into infinitely small pieces. And what we're going to use to do that? Integration. Just a second, let me grab this image.